How Populations Grow. Chapter 5, Section 1. Read by Maya White, script by Logan Tomlinson, movie by EricLoganMaya. For all of their differences, cheetahs in a savanna in Africa, llamas in a mountain valley in Peru, Americans in a city in America, populations have one fundamental thing in common. They grow. This comes with exceptions, since some species have gone extinct, as we know, but for the most part, they are inclined to increase in numbers. We are a perfect example. Having not exceeded the limits of our resources, humanity continues to grow. Let's look at what defines a population. There are three main things. 1. Its geographic distribution, or the area inhabited by whatever population you're looking at. 2. Its density, the number of organisms in a specific area. A population of bushes is denser than a population of trees in the same forest. And 3. Its growth rate. This describes how quickly, or slowly, a population increases in size. The number of bacteria in a petri dish increases in size somewhat faster than a herd of elephants. Therefore, you have a higher growth rate. The subject of population growth interests me. Let's talk about that for the rest of the video. There are two factors that directly affect the size of a population: the ratio of births to deaths, and the immigration and emigration to the population. The first is nice and straightforward. More births than deaths, a population gets bigger. More deaths than births, and it gets smaller. If the number of births and deaths is about the same, the population, obviously, will stay the same. And the second is a metaphor for the first one. A population grows if more animals come to it, and if less if they leave it. They might leave due to a lack of food or other resources, or immigrate into a new population due to the same problems. Exponential growth is the pattern that all populations follow, and it's not as complicated as its name suggests. The more organisms in a population, the more organisms that can be produced. To put it simply, if, say, a population starts out with 2 pairs, and each couple has 4 offspring, and the pattern continued like that, it would double every generation. Humanity doubles about every 40 years, so every 2 generations. We're actually not that far off from the example. A graph of exponential growth of a population looks something like this, where the x-axis represents the time that's passed, and the y-axis represents the number of animals. If nothing stops it, our hypothetical population here would keep growing until it covered the whole Earth. So why doesn't it? Why isn't the Earth just a big mass of plants and animals and protists and fungi? This horrifying mental image doesn't come into play because something does stop it. We call this logistic growth. That means a population only grows so long as its resources can sustain it. When it stops being able to grow, when it runs out of room to grow and animals start emigrating, when there isn't enough food to keep them alive, we say it's reached its carrying capacity, kind of like the maximum capacity signs you see in buildings or auditoriums. The population simply can't keep reproducing and stays where it is, resulting in a plateau or a flat line across the graph. Or the population even starts dying out if the resources don't replenish fast enough. So let's review. There are 3 important characteristics that define a population: its growth rate, geographic distribution, and their density. In addition, 2 main factors affect population size. They include the ratio of births to deaths and the comparison of immigration to emigration. How many organisms move into or out of a population. However, the main concept is that without a system of checks and balances, a population would grow infinitely and in a pattern called exponential growth. However, eventually it would slow down or stop because of the lack of resources. We call this logistic growth.